Hi, physical science students. In this video, we are going to be talking about metric factors. So up until this point, we learned how to gather information using measurements. We've also learned how to write those measurements as factors and say those factors as English statements. You also watched a little video about the SI and metric units and why we have them, and did a little bit of reading about some of these metric prefixes. So what we're going to do is take all that information and put it together to build some factors that we can use to change out units in the metric system. Now, to get us started, I want you to put on your thinking caps, and I want you to think about, why do we have metric prefixes? All right. Now, let me give you an example. This might help you out. Imagine I wanted to measure the length of the door in the classroom, but I had a pencil, my pen, my Post-it, and my paperclip. Which of those tools would be easiest to measure the length of the door? So think about which one would be easier and why. All right, likewise, let's say that we had a little eraser, so something like this. We had an eraser, and I wanted to measure the length of the eraser. Which measuring tool, the pencil, Post-it, paperclip, or pen, would be easier to measure that? All right, so there's really no right or wrong answer here, but I want you to think about something. If I had the length of the door, it's a pretty big length compared to my measuring tool. That's going to be easier if I use the pencil, a bigger measuring tool, to measure the length of the door. I don't have to use as many pencils as I would paper clips. Can you imagine trying to measure the length of the door in paper clips and someone walking in and you'd have to start all over, right? Likewise, though, the eraser is really small. So using the paper clip would be a better tool to use because the paper clip is small, just like the eraser. So the big idea here are these metric prefixes are helpful when we're measuring really big things and really small things. It helps us match up a unit that is better described by whatever we're trying to measure. So let's refresh our brains, right? We learned about 3 metric prefixes. These are the ones that you'll need to know. And I want you to think, what does centi mean, what does milli mean, and what does kilo mean? So think about what those different prefixes mean in terms of numbers. All right, so as a reminder, centi is 1/100th. The TH at the end tells you it's a fraction, 1/100th, and it means it's 100 times smaller than our base unit. So the big idea here is, remember that centi is 100. Just like cents in a dollar, there's 100 cents in a dollar. There's 100 years in a century. So centi is 100 times smaller than our base unit. Milli sounds like million, but it's not. It's thousand. It's 1,000 times smaller than our base unit, so 1,000th. Kilo, on the other hand, kilo also means 1,000, but it's 1,000 times bigger. That's why we see 1,000 over 1. And what we're going to do is use these fractions to create factors that we can use in our metric system. Now, you'll notice that these fractions are already close to factors. We're just missing those units in there. And what we're going to do is look at these different visuals for these metric units and be able to create those factors. What you're going to do is, you should have picked up a worksheet that has the this table on it. I like to think of this as like our little toolbox. We are going to put 2 factors in each box, so we can be converting from meters to centimeters, meters to millimeters, meters to kilometers, and then likewise for liters and grams. And we'll use this when we do our metric measurement lab later. So let's go ahead and get started. We'll fill out this first box here, or this first column, as we look at the meter. All right. So our meter, you've probably all seen a meter stick in your life. A meter is the SI base unit for length, which we said was the straight line distance between 2 points. Now, you probably don't normally measure with a meter at home, right? Our meter is like analogous to the English system's foot. So you would probably measure length in feet. In the SI units, we would want to measure in meters. And to give you a little bit of a visual, 1 meter is about 3.2 feet. You can kind of estimate that a meter is about 3 feet, okay? So we have the meter, and that's our base unit. But if we want to measure things that are smaller, we might want to use what we call the centimeter. You'll notice our symbol is cm, C for centi, and M for meter, right? Now, our centimeters are labeled actually on our meter stick. So these numbers don't represent meters. 1 stick is a meter. These numbers actually measure centimeters, and you can see that little cm there. Okay. Centimeters are analogous to the inch in the English system. I think that 1 inch is about 2.5 centimeters, but you can think about how we took a foot and broke down into inches. Likewise, we have a meter, we break it down into centimeters. So think back to this factor, right? 1 over 100, and what we need to do is figure out where our units would go. We have to ask ourselves, would it make sense to say that 1 meter is 100 centimeters, looking at our picture? Or would it make sense to say that 1 centimeter fits into 100 meters? So I'm going to ask yourself, which one of those makes sense? Remember, this top amount is supposed to equal the bottom amount, and we can use that to create factors. All right, so we should see that 1 meter fits 100 centimeters. It doesn't make sense that 1 centimeter can fit 100 meter sticks. And then remember, the flip-flop to that would be that 100 centimeters is equal to 1 meter, or 100 centimeters over 1 meter. Okay, make sure you add that to your sheet. And then let's go ahead and look at millimeters. So if you look closer at that meter stick, we see that in between every centimeter marking, there's 10 little markings, and these are our millimeters. Millimeters, mm is our symbol. And these are useful for measuring even smaller numbers, but also measuring things with a little bit more precision. So millimeter markers are smaller, those 10 smaller markings between each centimeter. And these are like analogous to quarter or fractions of an inch. You might have measured something as 2 1/4 inches. These millimeters are very similar to that. So if you have to think, there's 10 millimeters inside each centimeter, but then I have 100 centimeters. That's a lot of little markings. In fact, that'd be 1,000 little markings. So let's take a look at our fraction. Let's start to turn it into a factor by putting in our little symbols. Would it make sense if I had 1 meter stick, that there's 1,000 millimeters? Or would we say that there are 1 millimeter, 1 small millimeter, and 1,000 meter sticks? So think about what would make sense there as you build your factor. Once you check those, go ahead and put them on your sheet. All right, now we have the kilometer or kilometer. Our symbol is km for kilometer. And these are useful for measuring very large lengths, okay? This is very similar to the mile in the English units. If you've ever run a 5K, right, the K stands for kilometers, and a 5K race is equivalent to 3.1 miles. So a kilometer is actually smaller than a mile, but it's very similar. It's a pretty long length compared to these meter sticks. In fact, if you're familiar from going from SJA to OLA, Our Lady of Angels, that distance is actually a kilometer. It just happens to work out that way. So if you ever walk to OLA from St. Joe's, you walked a kilometer. So you have to think about kilo is 1,000 over 1. And we have to think, does it make sense that there's 1,000 kilometers in 1 meter stick? Or would we say that there's 1,000 meter sticks in 1 kilometer? So go ahead and build that factor and check it. And then write the reciprocal, right? Do the other factor with it. All right, now we'll be talking about volume. So volume, when we measure the space taken up by a liquid, we use the unit liter. Okay, and you're probably familiar with this. If you ever buy a 2-liter bottle of pop, just cut that in half and that's a liter. Sometimes bigger water bottles, so not your standard 16-ounce water bottles, but the little bit bigger ones, those are typically a liter as well. A liter is very similar to the English system's gallon. 1 liter is about 1/4 of a gallon, so you would need 4 liters to make up a gallon, but it's kind of that bigger unit of a liquid. Now what we can do is attach these prefixes to get units that are bigger or smaller. So a centiliter is useful for measuring even smaller So a centiliter is useful in measuring even smaller volumes. So actually about 1/2 tablespoon is equal to a centiliter. This isn't really used as much as some of the other prefixes, but it's really helpful to know. And again, it's very similar to the tablespoon in our English systems. So just like we saw with centimeter, a centiliter is going to start with that same base of our factor. So 1/100. And now we just have to think about where these units go. Thinking back to a liter is about half of a 2-liter bottle, would it make sense that to say in 1 liter, there's 1,000 of those centiliters or those tablespoons? Or would it make sense to say that 1 tablespoon is the same amount as 100 liters of water? So think about which one would actually make sense, build your factors, and then attach them onto that sheet. All right, next we have the milliliter. Our symbol is ml for milliliter. And these are useful in measuring even smaller volumes of water, or liquids, I should say. And then 1 milliliter is about the volume of 10 little droplets. So if you think of a droplet, if you put 10 of them together, it's about a milliliter. You've probably seen this when you've taken medicine before. Medicine cups usually have milliliter markings or droppers of medicine. But think back, you have a liter bottle, right? And you have these milliliters, okay, like droplets of water. Would it make sense to say that in 1 liter, there's 1,000 milliliters? Or would it make sense to say that 1 milliliter can fill 1,000-liter bottles? So think about what would make sense there and build your 2 factors. And again, remember to attach those to your sheet. All right, then we have the kiloliters. And I always joke, I've been trying to do this as a show and tell. I've always asked the principal to buy me a hot tub, and he always says no. But I always tell him it's a really good example of what a kiloliter would look like. I'm just kidding. But a kiloliter is helpful in measuring large volumes of water. And a hot tub is about 1 kiloliter of water. So if you think back to our liter bottle, right, our Aquafina bottle, is it going to make sense to say that 1,000 hot tubs can fit inside a liter bottle? If not, think, would it make sense to say that 1,000 liters or Aquafina bottles can fit into 1 hot tub? So think about what would make sense there. Build your 2 factors and add those to your sheet. All right, now we're going to start talking about mass. Mass can be measured using the unit of grams. And 1 gram is about the mass of a paperclip. Our symbol for gram is G. And if I want to measure something even smaller than a gram, I can use what we call the centigrams. Again, this one's not used as much as the other units, but it's still helpful to know. And if you want to picture a centigram, you take a paper clip, you actually cut it into 1,000 pieces. One of those pieces would have a mass of a centigram. So think back at how to build your factors here. Would it make sense that 1 gram or 1 paper clip can fit 1,000 centigrams? Or would we say that 100 centigrams fits into 1 gram? So think about what would make sense there and build your 2 factors. All right, now we have the milligram, which is even smaller than a centigram. Milli, remember, is 1,000th. And you actually see this a lot on food labels. If you look, we have milligrams listed all over here. And if you think back, 1 vitamin pill is actually pretty small. But now we're talking about things, there are tons of vitamins within it, and very, very, very small masses related to each of these particular vitamins and minerals. So a milligram is useful in measuring things that are even smaller than a gram. And we have to ask ourselves, right, if a gram is like a paper clip and we're using things that are even smaller, would it make sense to say that 1 gram, there are 1,000 milligrams? Or would it make sense to say that 1 milligram would fit 1,000 grams? So think about what would make sense there and build your 2 factors. All right, lastly, we have the kilogram, and the kilogram is actually the base unit for mass. It's the only SI base unit that has a prefix out front, and that's because for historical reasons, grams are actually really small. Kilograms are bigger. So it's easier to use the kilogram as our base unit. Our kilogram is helpful in measuring masses of objects that are a little bit bigger. And a kilogram is analogous to the pound. 1 kilogram is about 2.2 pounds. So 1 kilogram is actually heavier than a pound. When we look at this, we can think of dumbbells or weights. Usually they'll have however many pounds written on them. Some of them actually also have the kilogram rating on there. So these are 4-pound weights, but that would be very similar to, or it would be 1.8 2 kilograms. So thinking back, we said a gram was like a paper clip, and we have kilograms. Would it make sense that 1,000 paper clips fit into one of these kilograms? Or would it make sense to say that 1,000 of these weights, 1,000 kilograms, would be the same amount as 1 paper clip or 1 gram? So think about your 2 factors. What would those look like? Check them in this Edpuzzle and then record them on our sheet. So the last thing I want to say is be careful to make sure you have your correct factors written on this little toolbox here. Hold on to this toolbox. We're going to use it when we do our metric measurement activity later.